Last session, we stopped at the discussion of how to figure out dilution reactions and mixing of solutions. Got it? And today, we'll see how we can apply this to various solutions like acids, bases, and salts. As much as this topic is concerned, when you think about acids, we only regard here as strong acids. We do not go for acids which are weak acids. For instance, if I take HCl, I assume that all of that, all of the H plus will get completely ionized into all of the acid will ionize into H plus and Cl minus or respective ions. For example, if I take 100 moles, you'll get 100 moles of H plus and 100 moles of Cl minus. While H2SO4, if I take 100 moles, I'll get 200 moles of H plus and 100 moles of SO4 2 minus. So ions would be present in the equal amount. When I use the word weak acids, here I'm expecting that if I have 100 moles, probably very few moles have been ionized and rest of the moles are still remain unionized. And we have a separate chapter to discuss about weak acids, so we'll not get into that details right now. So we only consider cases where we have the mixture of acids, okay, which are strong acids or strong bases. For instance, if I take 10 ml of HCl, 20 ml of H2SO4, and 30 ml of HNO3, all of them are mixed together, and I'm supposed to find out the final concentration of H plus ions. Then, what we shall do here? So, first, try to figure out if HCl is ionized, right? In case if HCl is ionized into H plus and Cl minus. So, we will be having 10 into zero point 0.1, which makes it 1 millimole. So originally there was 1 millimole present. And that 1 millimole, okay, here, 1 millimole will get completely ionized. That 1 millimole will get completely ionized into formation of 1 millimole of H plus and 1 millimole of Cl minus. Similarly, if you have H2SO4, correct, I can say we will have 2 H plus and SO4 2 minus. Therefore, originally I have 20 into 0.2 millimoles, which makes it 4 millimoles. So if I had 4 millimoles, okay, if I had 4 millimoles, that 4 millimoles will be completely ionized to form 8 millimoles of H plus and 4 millimoles of SO4 2 minus. Clear? Just a second. Right. Likewise, in case if at all I take the same thing for HNO3, so what will be the case? In case of HNO3, right, it will convert into H plus and NO3 minus. Correct? One second. Right. So check what is given. It is given as 30 ml into 0.3, which makes it 9 millimoles. So the entire 9 millimoles will ionize into 9 millimoles of H plus and 9 millimoles of NO3 minus. Correct? Now you got to add the total number of moles of H plus ions. Okay? That is the number of H plus ions coming from HCl plus number of H plus ions coming from H2SO4 or number of H plus coming from HNO3. If I add all of it, I get 1 plus 8 plus 9, which makes it 18 millimoles. So 18 millimoles of H plus are present. And what's the total volume of the solution? Which is 10 plus 20 plus 30, which makes it 60 ml. Now, molarity can be defined as number of moles by volume, where we can write this number of moles in millimoles upon milliliters, or we can write it as moles upon liters. Hence, I can write molarity of H plus will be equal to total number of moles of H plus upon total volume, which will be equal to 18 millimoles upon 60. Got it? Clear on that? So that will be 3 by 10, or which is 0.3 molar. Okay? Or we simply write this as 0.3 m. So that would be the concentration of H plus ions. Okay? Just to give you more clarity on the other ions, see, Cl minus concentration will be 1 by 60. SO4 2 minus concentration will be 4 by 60. NO3 minus concentration will be 9 by 60. These are the concentrations of the other ions. So I'm sure you guys understood this point, how to figure out concentrations of various ions when they get ionized. Clear, everybody?
Yes, sir. So can I just write this now?
Sure. What if we have acid-base reactions, everybody? So first need to understand what are bases. See, anything which gives OH minus very easily, like NaOH, KOH, calcium hydroxide, these all we regard as bases. In fact, there are many different types of bases. For now, let's restrict ourselves to these bases. Now, if these acids, if at all they make a reaction with NaOH, they would form salt and water. While doing so, we might be providing acids and bases in an quantity where their stoichiometric balance is observed, or in certain cases, some acid might be excess or base might be excess. In such cases, there will be some amount of H plus will be still present in the solution, or some amount of OH minus still present in the solution. Got it? So these kind of questions are normally asked during the, in this particular topic. Check. First, let's understand this term neutralization. It's the principle of acid-base reaction where they always react in their stoichiometric proportions. After the neutralization, no acid or no base is supposed to be left. Instead, only salt should be formed. So when the equal quantity, the quantity that you have given is mapping with the ratio of their stoichiometric coefficients for acids and bases, then we get only salt. Check this case here. I have 400 ml of 0.1 molar NaOH that's treated with 400 ml of 0.05 molar H2SO4. I got to find out concentration of H plus or OH minus left in the solution. So first I'll check out, the reaction that might be happening. 2 moles of NaOH will react with 1 mole of H2SO4 to get Na2SO4 plus 2 moles of H2O. This is what you will get. Now, to put the number of moles, I can write this as 400 into zero point 0.1 and 400 into 0.05. So that makes it 40 millimoles, and here it will become 20 millimoles. Now, compare the stoichiometric ratio and notice once. For every 2 moles, I'm expected to react with 1 mole. That means I require 2:1 ratio for complete neutralization. So for 2 moles, 1 mole is required. So for 40, how much is required? 20 millimoles is required, which is perfectly given, which means neither I'll have NaOH left nor I'll have Na2SO4 left. Everything will be formed as, now see the ratio. For every 1 mole, I would be getting 1 mole of Na2SO4, which means I will get 20 millimoles of Na2SO4, while for every 1 mole, I'll get 2 moles of water. So that makes it 40 millimoles of water is formed. Got it? This is what you'll have. So therefore, if I say H plus is not present here, OH minus ion is also not present here. There is hardly any H plus or OH minus present here. And what is left is Na plus concentration. Now, for every 1 mole of Na2SO4, there are 2 moles of Na plus present in it, isn't it? For instance, if I take Na2SO4, which is also going to be in the ionized form in aqueous solution, hence, if I had 20 millimoles here, so which means this 20 moles will be completely ionized to form 40 millimoles of Na plus and 20 millimoles of SO4 2 minus. Therefore, if I check Na plus concentration, it will be 40 upon total volume. In this case, 400 plus 400, that makes it 800. Similarly, SO4 2 minus, that will be equal to 20 divided by 800. Okay, this will be the ion concentration. Now, since I'm noticing that there is no H plus and no OH minus, should we write the answer as 0? Apparently no. Why? See, when there is only salt water, or we have pure water, then H plus and OH minus concentration would be equal, and they will be approximately 10 raised to power of minus 7 molar. Okay, 1 second. Yeah, keep the volume low. So the H plus and OH minus concentration would be approximately 10 raised to power of minus 7. So by chance, if you are getting a completely neutralized solution, which means acid and base is completely neutralized, there is no H plus or no OH minus present, which means you will report the answer as 10 raised to power of minus 7 molar. Hey guys, I hope this part is clear. Any doubt? Nitya, any doubt, Vita?
No, sir.
Dev, Manav?
No, sir.
No, sir, no.
Okay. If you wanted to write, just complete this part. Now, let's see this. I have just changed the data in the same question. This time, I have 400 ml of 0.05 molar NaOH that is treated with 400 ml of 0.1 molar H2SO4. Okay. Find the concentration of OH minus or H plus left in the solution. Okay. So notice H2SO4 plus 2 moles of NaOH giving Na2SO4 plus 2 moles of H2O. Okay. This is the overall reaction we just learned. Now, check out what we can do. H2SO4, number of moles, please write it down. So we have 400 cross 0.1. NaOH, we have 400 cross 0.05. Okay. So that makes it 40 millimoles. Here that makes it 20 millimoles. Correct. Now, as per the data, for every 1 mole, we require 2 moles of NaOH. For every 1 mole, we require 2 moles of NaOH. For 40 millimoles, how much it is required? For 40 millimoles, we require 80. But how much it is given? Given only 20. Correct? Which means NaOH is a limiting reagent. This is limiting reagent and this is excess reagent. Okay? In such case, the reaction will, as per principle of limiting reagent, we learned that now the reaction will drive on the basis of only limiting reagent. So if for every 2 moles, 1 mole of H2SO4 is required, then for 20 millimoles, how much it is required? Only 10 moles are required. 10 millimoles are required. Correct? So only 10 millimoles are required. So 30 millimoles will be left. This will be the left amount. And nothing will be left from NaOH because that's limiting reagent. And now for every 2 moles, 1 mole of Na2SO4 is formed. So for 20 millimoles, you will have 10 millimoles will be formed. So 10 millimoles of Na2SO4 will be formed and 20 millimoles of H2SO4, H2O will be formed. And now notice H2SO4 which is left over, because H2SO4 is left. You know that H2SO4 will get completely, because it's a strong acid, get completely ionized into 2H plus and SO4 2 minus. And as I said, we have total of 30 millimoles. Since we have 30 millimoles, what I can say, these 30 millimoles will get completely ionized into the solution now. This gets completely ionized into the solution and convert into 60 millimoles of H plus and 30 millimoles of SO4 2 minus. Okay. Now I can clearly say that there is there is sufficient amount of H plus present now. So therefore, number of moles of H plus will be 60 millimoles, which is present, and total volume will be equal to, how much was the mixing of volume? 800 ml. 800 ml. Therefore, the concentration of H plus ions will be equal to 60 by 800. 60 by 800. Got it? So that makes it 3 by 40. Got it? So 3 by 40 molar or 3 by 40 mole per liter. This is the way you will represent the concentration. Clear? By chance, if the question is also asked, figure out what is the amount of SO4 2 minus. So concentration of SO4 2 minus. See, the concentration of SO4 2 minus, you can notice that there are 30 millimoles generated here and there was another 10 millimoles generated here. So total we have 40 millimoles. So that will be 40 millimoles divided by 800. Similarly, what if I ask Na plus ions? Na plus ions is double of this one, which is 20 millimoles upon 800. Okay, so that's how you can figure out the rest of the ions which is to be required. So please check it out quickly. Right, so I'll just borrow these equations from the old one here. Just a minute. Second. So let me rewrite that. So in case if you have 2 moles of NaOH plus H2SO4, then you'll have Na2SO4 plus 2 moles of H2. Okay. So now if you find the number of moles, it will be 400 cross 0.1 and this is 400 cross 0.01. That makes it 40 millimoles, while here it becomes only 4 millimoles. So 2 moles require 1 mole, 40 requires, okay, 20. Okay, so but only 4 is given. That clearly tells us that this is the limiting reagent. This is the excess reagent. Okay. So now notice this one. So now notice this. So since it is 4 moles, for every 1 mole, if 2 moles is required, 4 moles, we just require 8 moles. So just subtract that 8 moles. So 8 moles has been used. So if 8 moles have been used, so we will have this as 32 millimoles left. This will be the left amount. While nothing of H plus will be left over. And for every 1 mole, we'll get 1 mole of Na2SO4. So for 4 moles, you'll get 4 moles of 4 millimoles of Na2SO4 and 8 millimoles of water. And now, since it is NaOH, NaOH will get completely ionized to form Na plus and OH minus. So if there is 32 millimoles, okay, if there is 32 millimoles, all of that will get ionized to form 32 millimoles of Na plus and 32 millimoles of OH minus. Therefore, OH minus concentration will be equal to 32 millimoles by total volume. Total volume in this case, we took it as 400 plus 400 only, which is 800. Okay. So that makes it 4 by 100 or 0.04 molar. So that will be the concentration of OH minus. Is this reaction clear, everybody? Please check. All okay?
Yes, sir.
Great. Right. So we have lots of application based on these cases.